It's so easy to take that cool air in our homes for granted, but the system that's providing it, it's fighting a constant, invisible war against the elements, day in and day out. In this explainer, we're going to pull back the curtain on that battle to show you what your HVAC is really up against.
We have all been there, right? It's the absolute most brutal day of the summer, and then nothing. Silence. The cool air just stops. I know, it feels like a conspiracy, like it's planned, but it's actually just the tragic, predictable end for a system that's been pushed way beyond its limits. So, what exactly is doing all that pushing?
To really understand this, we're going to head to a true climate battleground, Katy, Texas. The environment in this region is uniquely harsh, and it puts an incredible, almost unbelievable strain on home comfort systems. That makes it the perfect case study to see the very same forces your own system might be facing.
Okay, just look at this for a second. The sheer workload is insane. In a place like Katy, your air conditioner isn't just a summer thing, it's an 8-month marathon. That is double the national average. I mean, imagine running your car for twice as many miles every single year. The wear and tear is just immense.
And it's not just the heat. The first enemy we have to talk about is this constant, crushing humidity. When it's over 70% outside, your AC isn't just cooling the air anymore. It's also moonlighting as a heavy-duty dehumidifier. On a really sticky day, a properly working system can pull over 20 gallons of water out of the air. That's a huge extra burden to put on it.
Then, of course, comes the oppressive heat. And we're not just talking about the number on the thermometer. A heat index of over 110 degrees is what it actually feels like, and that's what your system has to fight against. During these heat waves, units can run almost non-stop for weeks on end, pushing every single component right to its breaking point.
But, there's a hidden threat, one that attacks from below the ground. A lot of this region is built on what's called expansive clay soil. This stuff literally swells up when it gets wet and then shrinks when it dries out. That means the foundation of your house is constantly shifting. It's a slow, silent pressure that creates major problems inside your walls.
So all these environmental forces, the heat, the humidity, the shifting ground, they don't just disappear. They show up as real mechanical breakdowns. We like to think of the most common ones as the 4 horsemen of HVAC failure, and each one is born from the tough conditions we just saw.
And you can draw a straight line from the cause to the effect. That constant running for months on end, that leads to compressor failure. That shifting clay soil, it tears apart your ductwork. And all that extreme humidity and the gallons of water it creates, that clogs up your condensate drains. The overall strain just leads to poor airflow, which can freeze your coils solid.
Let's just follow one of those to see the chain reaction. It's pretty wild. First, the system pulls all that moisture from the humid air. That constant flow of water lets algae and mold grow inside the drain line, creating a clog. Well, now the water has nowhere to go, so it backs up, overflows the drain pan, and starts dripping right into your ceiling. A small HVAC problem very quickly becomes a huge, expensive water damage problem. And hey, remember that shifting soil? This is the consequence. As your home's foundation moves, it literally pulls the ductwork apart at the seams. And look at how wasteful that is. Up to 30% of the air you paid good money to cool is now just dumping into your hot attic. You're not just wasting energy, you are hemorrhaging money. And your system has to work even harder to make up the difference. It's a vicious cycle of waste and wear. Okay, so that's the problem. And yeah, it's intense. But knowing the enemy is half the battle, right? So let's pivot from the problem to the solution, because understanding what professionals should be doing empowers you, the homeowner, to demand much better service. The absolute cornerstone of any professional installation is something called a manual J load calculation. Now, this isn't a guess based on square footage. No way. It's a real engineering formula that takes everything into account. Your windows, your insulation, which way your house faces, your local climate, to figure out the exact size system your home needs. Not too big, not too small, but just right. And this table shows you exactly why that precision matters so much. See, a system that's too big, which is a really common result of guesswork, will blast cold air, cool the house down way too quickly, and then just shut off. This is called short cycling. It doesn't run long enough to pull out all that crushing humidity, and the constant starting and stopping is like death by 1,000 cuts for your equipment, leading to early failure. Professional sizing, on the other hand, avoids all of that.
So what should a quality service call actually look like? This isn't just a checklist, it's really your right as a customer. It's got to start with a thorough diagnosis, using proper digital tools, not just a hunch. Then, you should get a clear, written estimate that you approve before any work begins. And finally, a quality repair using the right parts, followed by testing to prove the problem is actually solved. No mystery, no surprises. Simple as that.
Sooner or later, every homeowner faces the big, expensive question. Do you keep pouring money into repairing an aging system, or is it finally time to replace it? It's a really tough call, but there's a simple tool that can help guide you.
It's not just about the cost of today's repair, it's about the total cost over the long haul. So, when does the math finally tip in favor of getting a new, more reliable, and way more efficient system? Well, there's a simple rule of thumb that can really help.
Meet the $5,000 rule. It's a great little formula to help you make this call. You just multiply the age of your system in years by the estimated cost of the repair. If that number is more than $5,000, then replacement is probably the smarter financial move. For instance, let's say you have a 12-year-old unit and a $500 repair bill. 12 times 500 is $6,000. That's a strong signal to at least start looking at your replacement options.
So after going through this extreme case study, what are the lessons that all of us can apply, no matter where we live? It really all boils down to being a smarter, more informed owner of what is probably your home's most important and expensive system.
So here it is, your action plan. First, know what you're up against. Take a second to understand your local climate-specific challenges. Second, professional maintenance isn't a suggestion. For a system's survival, it's absolutely essential. Third, if you ever replace your system, you have to insist on a manual J calculation. And finally, be realistic about its lifespan. In a brutal climate like Katy's, it's 12 to 15 years, tops, but neglect can cut that down to just 8.
And that leaves us with this one last thought. Your comfort system is a hard-working machine, running an annual marathon against heat, humidity, and just time itself. It runs for thousands of hours a year. So after everything we've seen, the real question is yours ready for its next fight?